Welcome back. This video will be focused on the PIC24 FV32K304 family of microcontrollers CPU. So if I just flip to the datasheet quickly, I got this information from the datasheet here, and I've just collated it so that we can simplify the process for you because there's a lot of information here. But if you'd like to read through the datasheet, it has a lot of great information that I'm not necessarily referring to, but I'll try my best to give you the nuts and bolts of what the CPU is about. So the PIC24 is a 16-bit MCU or microcontroller unit which uses Harvard architecture, which simply means that there are different buses used to access program memory on the left here, where you can see, which is where your program goes and your code goes, and there's another separate bus here you can see to access data memory, which is where your variables are stored. So in a PIC24, a 24-bit bus is used because program memory has 24-bit wide instructions, and then it has this 16-bit wide bus here between the CPU to access the data memory, which is 16 bits wide. So you look at this CPU core, there's a lot happening here, but just to break it down for you simply, we are using an internal clock on this PIC, which is operating at a speed of 8 megahertz. Okay, and we have a program counter, which simply advances the program instructions starting at 1 to the next instruction. It keeps track of those. And the ALU, or the arithmetic logic unit, which is down here. Okay, and then we have program memory, which is where the program is stored, which is up here. Okay, and then we have data memory, which is up here. Okay, you can see those data bus is up here, and we have also the address bus, which is down here. Okay. So the ALU is part of the CPU, which we use combinational logic, and we know this from our work in grade 11 when we made adders and subtractors. And the nice thing about the CPU is that it takes only usually one instruction cycle to complete one instruction. Some take more than one, some take two, but most take one. And this is the part where in the ALU where we deal with logical operators, relational operators, and most things pass through this ALU. The arithmetic operators, as we know them to be addition, subtraction, multiplication, and division, I've got here that it takes 19 instruction cycles, which is a lot, which is not very efficient when compared to the single instruction that most of these require. Talking a little bit about instruction cycles versus clock cycles. 2 clock cycles are required for every instruction cycle, and we refer that as the fetch and execute of a CPU. So it has to fetch that instruction from the program memory and then execute it, and that takes 2 clock cycles. So if we are dealing with an internal clock of 8 megahertz, and it takes 2 clock cycles per instruction cycle, then really what we're talking about is it's 4 million instructions that are being executed, fetched and executed every single second. And we call that MIPS. So 4 MIPS, you may see that, which stands for millions of instructions per second. So this, because we're at 8 and it's 2 clock cycles per instruction cycle, we're operating at 4 MIPS. Okay, let's look at program memory. Program memory is non-volatile memory. Okay, so it's permanently etched into the flash RAM of the PIC. And it can be electronically erased and reprogrammed multiple times. We've already said it's 24 bits wide, you can see here. And as a result, we have exactly 11,264 instructions available. Okay, so that's where all our programs go. We will very rarely ever have to worry about running out of space when writing our programs. The 23-bit program counter contains the address, okay, for fetching that next instruction in program memory. So that's the significance of that PC. Data memory, okay, is volatile, and we know this because of our 3x2 memory circuit. And unlike the program memory, it is 16-bit wide registers, which are made up of these MSBs and LSBs. So most significant byte, okay, and a byte is 8 bits, and then the least significant byte here. It has 2 major sections that we're going to need to be concerned about. The SFRs, which are the special function registers at the top here, and the data RAM, which is right below it. So the SFRs occupy the first 2 kilobytes of that RAM. And they're used by the CPU and peripheral devices for specific operations. One of those, as an example, would be the lat A or lat B. When we're trying to output, maybe turn on an LED, for example, we have to write to those ports. Well, those ports are registers that are located in the SFR space. Data RAM, okay, occupies the next 2 kilobytes of memory, and the first address is 2048 because from 0 to 2047 is occupied by the SFRs. We don't really need to know that, but we do need to know that this is where we put our variables. So they're empty registers where your variables will be stored. These SFRs, however, are already occupied by those different registers that do various things for the PIC. All right, and that concludes our little presentation video on the CPU.